So today we're going to look into Pure Maths 1, February, March 2025, question number 5 until question number 8. So let's go into question number 5. For question number 5, an arithmetic as a first term is 5. So I just list out here. So it's A equal to 5 and my D equal to 6. And we need to find the sum of the whole terms lies between 150 to 400. So what we do, we find the very first term, which is more than 150. So for that, we can use the Tn formula, which is a plus n minus 1d. So this will my Tn 150. So I just make it 150 is equal to a plus n minus 1d. Okay, so n minus 1 is equivalent to 24.167, therefore n equal to 25.167. So the very first term, more than 150, is going to be n equal to 26. Okay, and similar method we use for the 400. So we find 5 plus n minus 1 6 equal to 400. Therefore n minus 1 will be 65.833. Therefore n equal to 66.833. So the last number is going to be n equal to 66. Okay, we only take the integers, okay, because the number of n cannot be a decimal number. So means we're going to find T26 plus T27 plus T28 plus all the way until T66. So this is what we're going to find. Okay, so if I want to do S66, so S66 will be from, like, for example, T1 plus T2 plus all the way until T25 plus, correct? So if you need notice, I only need this. I can make it. I only need this. I only need this, whereas this one I does not need. So T1 until T25 is actually S25, correct? So I'm going to put S66 minus S25. Okay, so S66 will be 66 over 2a plus n minus 1 d. Okay, we use the sum of formula. The sum formula will be Sn equal to n over 2a plus n minus 1d. This is the formula. Okay, so it's going to be 13200, and S25 will be 25 over 2, 25 plus 16, which is going to be 1925. So S66 minus S25 is going to be 13200 minus 1925, which is going to be 11275. Okay, so for question number 6, the diagram shows a circle with center C and the radius R, where x more than 0, y more than 0, or for all points of C. The least distance between any point on C and the x-axis is 8. So the least distance, so normally we'll take somewhere from here, the least distance from x-axis. So this could be the least distance from x-axis, which is 8. And the least distance between any point on C and the y-axis, so this could be 5. Okay, so say the coordinate of center in terms of R. So this one will be R and this one will be R. Therefore Your x-axis will be r plus 5 and y-axis will be r plus 8. Okay, that's it. And then, given that the distance between the origin and the center is 15 units, find the value of r. Means here the question said this particular distance. I'm sorry. Okay, this distance is 15. So means we can make it your distance formula. So I can just write here. The distance formula will be x1 minus x2 square plus y1 minus y2 square. Okay, where I can make it my x1 as this. Okay, so it's going to be square root r plus 5 minus 0 square plus r plus 8 minus 0 square. So the distance is 15 unit. So it's going to be, you square this, r minus 5 minus 0 is 0, so it's going to be r square, I'm sorry, plus 10r plus 25 plus r square plus 16r plus 64 equivalent to 15 square. Okay, I bring the square to another side. Sorry, square root to another side. So it will be 2r square plus 26r. It is actually should be r, and you rearrange the 15 square to the left hand side, so it will be minus 136 equal to 0. So I can do everything with 2. So r square plus 13r minus 68 is equivalent to 0. So my r will be r minus 4 and r plus 17 is equal to 0. So r equal to 4 and your r equal to negative 17. Since the r is the radius, so your r must be a positive number. Therefore, r equal to 4. This is the only answer. So this is not applicable, or you reject. So we reject this. Okay. For question C, the point on the circle is the furthest from the origin denoted by P. Find the gradient. Find the gradient of tangent P at circle. Okay. So you said the distance is further will be here. Okay, so this is the point P actually. Point P. Okay, and the tangent to the circle is going to be this. Okay, and this should be 90-degree. So what we can do, if you are able to find the gradient of this point, okay, the gradient of this particular point, so we find this is m1 and this equal to m2. We can do this. So since it's a 90-degree, so we can set m1 times m2 equal to negative 1. So we try to find the gradient of this point. Okay, we find the gradient of this line m1. So since we know the coordinate here is 0, 0, and the coordinate here is actually r plus 5. Just now my r is 4. So r plus 5 will be 4 plus 5 is 9, and r plus 8, so is 12. Okay, So I think by using these two coordinate, we can find the coordinate m1 ready. So my m1 will be what's coordinate just now? 12 over 9. Okay, so 12 minus 0 over 9 minus 0, which is 4 over 3. Therefore my m2 will be negative 3 over 4. So you can use 4 over 3 times m2 equal to negative 1. So m2 is equivalent to negative 1 divided by 4 over 3. So you get 3 over 4. Okay. Question number 7. So question number 7, show that tangent square theta plus 5 sine square is equal to this. Okay, so usually when I have this kind of questions, right, so I will try to make it in term of common fraction first, because here I got tangent. So I got tangent, so tangent square I can make it like a sine square over cos square. So 3 sine square theta over cos square theta plus 5 sine square theta. Okay, and then I make the common denominator. Since here I got cos, here I don't have anything, so I make a common denominator. So it's going to be 3 sine square theta plus 5 sine square theta cos square theta over cos square theta. So my next step, I have here sine power of 4, and I don't have anything in terms of cos, so I try to change all my cos into my sine. So by using the trigonometry identity, cos square theta plus sine square theta equal to 1. So cos square theta equal to 1 minus sine square theta. Okay, so 3 sine square theta plus 5 sine square theta, and cos theta will be 1 minus sine square theta over 1 minus sine square theta. So 3 sine square theta plus we multiply in 5 sine square theta minus 5 sine power of 4 theta over 1 minus sine square theta. So it's going to be 8 sine square theta minus 5 sine power of 4 theta 1 minus sine square theta. So yes, we prove this. Okay. Hence, solve the equation of 3 tangent from 0 to 270. Okay, so for this case, we look back this. Uh, since they already mentioned my 3 tangent is equivalent to this, so I can use this filler. No worries. Let's say you're not able to show or you're not able to prove this identity, you still can use from the question. It doesn't matter. So it's going to be, instead of 3 tangent square, I'm going to write here, instead of this, I'm going to replace this with 8 sine square theta minus 5 sine power of 4 theta over 1 minus sine square theta equivalent to 9. So you multiply up, it's going to be 8 sine square theta minus 5 sine power of 4 theta equal to 9 minus 9 sine square theta. Rearrange 5 sine power of 4 theta minus 17 sine square theta plus 9 equivalent to 0. And actually it's a quadratic. So if you're not able to see the quadratic, maybe we can rewrite this as 5 sine square theta square minus 17 sine square theta plus 9 equal to 0. So this is a quadratic form. So we factorize this. We cannot use the form factorizing. So we use the quadratic formula. Okay. So sine square theta is equivalent to negative b plus minus, or I just introduce minus plus only, plus square root b square minus 4ac minus 4ac over 2a. Just use it plus minus. Easier for me. But I need to write 2 times. Okay. Sine square theta will be 17 plus sub 109 over 10, and this one will be sine square theta will be 17 minus sub 109 over 10. Okay, so 17 plus 109 divided by 10. So for this I will get sine square theta equal to 2.744. Therefore sine theta will be plus minus 1.657. So your sine theta cannot be more than 1 or negative 1. So your sine theta, must be, it must be from negative 1 to 1. It can be more than this. So this one we reject. Okay, so we proceed with this, where sine square theta will be 0.65597. Therefore sine theta will be plus minus 0.8099. Okay, then for reference angle, you can choose not to do this. Okay, you can choose not to do this because it's already reject here. So for reference angle, it will be 54.088. And since sign positive and negative, it's going to be accumulate first quadrant, second quadrant, third quadrant. Why? And here the only gave from 0 to 270, so it's only from first 3 quadrant. Okay, therefore your theta is going to be 54.1 degree. Your second quadrant will be 125.9 degree, and the third quadrant will be 234.1 degree. Okay, so first 3 quadrant only. So maybe I can write in detail for this. So for first quadrant will be, it's just reference angle. For second quadrant will be 180 minus reference angle, and for third quadrant will be 180 plus the reference angle. So this is my reference angle. So if first quadrant, you can directly take this answer 54.1. degree, and make sure you put your degree symbol because they ask in degree. Okay, and if you never put the symbol on top here, if let's say you forget to put this symbol, then it is considered as a radian and your answer is totally wrong. Okay, and for second quadrant it will be 180 minus the reference angle, so you will get 125.9, and for your third quadrant will be 180 plus the reference angle. And let's say I want to find for fourth quadrant, it should be 360 minus your reference angle. Okay, for fourth quadrant, just take note on that. Okay, so we go to question number 8. A geometric progression is a such. The second term is negative 120, and the sum infinity is this. Okay, we just write this, find the common ratio. So second term t2 equal to negative 120, and sum to infinity will be 160. Okay, so here a r equal to negative 120. So my a is equivalent to negative 120 over r. Whereas sum to infinity, the formula will be a over 1 minus r equal to 160. So my a equal to this, so I can rewrite this as negative 120 over r bracket 1 over 1 minus r equal to 160. So negative 120 over r minus r square equal to 160. So negative 120 equal to 160r minus 160r square. So you rearrange and divide everything with uh, 40. Okay, so you will get 4r square minus 4r minus 3 is equivalent to 0. Okay, so you divide everything with 40 and rearrange. Okay, do everything with 40. So you can get 2r minus 3, 2r plus 1 equivalent to 0. So my r is equivalent to 3 over 2, and my r equal to negative 1 over 2. Okay, and since here there is a sum to infinity, when this word is there, which means your r modulus r must be less than 1, which implies that it must be from negative 1 to 1. So your r, this one is reject. Therefore, my final answer, my r equal to negative 1 over 2. Okay, you only use r equal to negative 1 over 2. Now, the first 9 terms in the progression now are removed. Find the sum of infinity. So it means from t1 all the way until t9 is removed. So now you need to find the sum of infinity from t10 onwards. Okay, this is what the question asks you. Okay, you need to find this. So what we do now, our a changed from t1 to t10. So I must find the a first. So for that, it's going to be ar is equivalent to 120, negative 120. So my r, sorry, is equal to negative 1 over 2, we should from earlier. So a equal to 240. So I need to find my new first term, which is t10. So my t10 is going to be ar power of 9, ar power of n minus 1. So it's going to be 240, 1 over 2, 9. So it's going to be negative 15 over 32. Okay, so now in order to find the new sum of infinity, so my a is equal to negative 15 over 32, my new a. Okay, this is for my new term. After remove, first 9 terms. Okay, so my a equal to negative 15 over 32, and my r remains the same, negative 1 over 2. Therefore, sum to infinity will be a over 1 minus r. Okay, so you will get negative 5 over 16. Okay, so that's all from me. Thank you.